So I got to move this guy. Anybody know MC Escher? You guys know MC Escher?
Painter.
Anybody ever seen the movie Labyrinth with David Bowie?
He's the one that.
Remember that at the end, all the staircases that were like all crazy, and David Bowie goes around? No? Okay.
Yes.
That's MC Escher idea of stair. He's got a one staircase that goes up or down forever, depending on which way you go. It's an optical illusion for the most part. Anyway, sorry.
Oh, is that the one that's like in a circle?
Yes. So like on the top of a
Yeah.
castle parapet or something,
Yeah,
and
yeah.
if you go one way, you're just always going up. And if you go the other way, you're always going down.
I've only ever seen it like in a cube, not in a circle. Like in
Oh.
if it's not a circle, it's pretty square.
True, but it's not really a circle. It is round. It is
Yeah.
squared off. Yeah,
Yeah.
yeah, yeah. Okay. So your homework is to watch. No. All right. So going back to the way I defined spread. I'm making a nice short set of data just so it's quick to work with. Correct. Which one of these data sets should have a larger spread number? What does spread mean again?
How far from the average it is?
How far from the mean the data points get on average. Right? So which set of data gets further away from its mean on average? Data set 2, yes? What's the average of both? 3. I love it. This data set gets further away from the average on average. You guys with me? Because 3 of these are 0 away from the average, and only 1 of these is 0 away from the average. So this one gets further away from its mean on average. Okay. So here's a specific definition for spread that will inform our formula creation. Spread is, oh God, I have so many markers, but so few of them work. A spread is the average distance from the mean to each data point. So let me ask you kind of like a silly question. If I wanted to know the average shoe size in this room, what would I need a list of first? Shoe sizes. Okay, I told you it was silly. If I wanted to know the average length of dog's tails, what would I need first? A list of
Dog's tail.
dog tail lengths, right? If I want to know the average blank, what do I need a list of? A bunch of blanks, whatever the shit that is. Yes? So what do I want the average of? The average distance from the mean to each data point. So I need a list of distances from the mean to each data point. Does that make sense? The only way I can calculate an average something is to have a bunch of those somethings, and then I can add them up, divide by how many there are. Yes? Okay, maybe. All right. One little weird thing here. Let me see if you guys are cool with this. It doesn't matter if you are. Populations can be any size. I'm saying these are both populations. Okay, this is going to become important in a minute. Because the formula for a sample is going to have one difference from the formula for a population. So we're going to do the population first because that's the most immediately obvious one, and then we'll talk about how a sample is different. Okay, here we go. So we're gonna. This is the making the sausage. We're actually gonna construct this formula. I'm obviously gonna push you in the right direction, but I want you to kind of agree with each step. So let's do number 1. We'll do number 1 together, and then I'll have you guys do number 2, or maybe we'll do 2 together. I don't know. We'll figure it out. So on data number 1, let's do this. Let's make a list like this, like we did the first day a few times. Just list it like this. What's the operation I'm going to use to figure out how far away each data point is from the mean? What operation tells me how far away something is? Subtraction, right? Okay, so I'm going to do this. I'm going to do each data point minus the mean. So why am I using that symbol? Because these are populations. Cool? The little Greek letter mu is population mean, x bar, sample. Can we stop for a minute? I really want you guys to agree. If I want I want an average distance each data point is from the mean, so of course I need a list of distances each data point is from the mean, so I can add them up and divide how many there are. So what is 1 minus 3? Holy shit, what's 3 minus 3? 0. 3 minus 3, 0. 3 minus 0. What's 5 minus 3? 2. Now, does anyone notice an issue if I try to take an average of those numbers? What do they add up to be?
0.
Of course. In fact, I don't care what data you make up. If you do each data point minus the mean, you will always get numbers that add up to be 0. Do you all agree that that's not good? Every calculation I make is going to be 0. Will that tell us anything? No. And of course, some of you guys know what's happening here. Distance. Can distance be negative? No. In fact, I mean, you're 4 feet away from me. I don't care if I turn around, right? If you're negative 4 feet away from me, you're inside me. You're saying, Wade. Right? That's a little weird. Let's not do that.
I thought you were about to talk about Magic School Bus.
I don't know that reference. I was talking about.
Swizzle?
Huh?
This whistle?
Yeah, I'm sorry.
Oh, damn.
I was too old for that when it came out, or I just never watched. So, one thing I could do. Does anyone know mathematically what calculates distance mathematically? Anybody? What do I do mathematically where the answer is always positive? Absolute value. I'm going to make this a little quick. One reason, there are a few reasons why we don't use absolute value here. One reason is, and this is not that big of a deal, but I do want to talk for a minute. Does everybody remember absolute value looks like this if you graph it?
Yeah.
What's the absolute value of 1? 1. What's the absolute value of negative 1? 1. Would you want to be in the plane, if the plane was flying like this and it did that, would you want to be in that plane?
No.
We are all dead if we're in that plane. All right, everybody, you're boom. We're against the side. We're all dead. Oh shit. So mathematically, math does not like these kinks, right? That's sort of like taking a hose and putting a kink in it. What's another function instead of absolute value that will make the output positive or 0? Squared. And what's that look like? That is a plane I can be on, right? We're gonna turn. Okay, fine. Okay, the other plane, people are dead against the wall. I'm much happier in this plane. I am not getting deep in the math, but to be honest, it's not that far away from what's really wrong. There are a few other reasons, and again, the main reason we're about to square is because I don't want anything negative. What does that mean I'm going to have to do at the end? So I'm going to have to take a square root at the end. Does that make sense? If these represent number of dogs people own, this is going to be square dogs. What the shit is that Picasso crap all about? What? I don't want to be at your house with your little 2.5 kids and your square dog. Okay, sorry. Actually, maybe I do. The square dog one is, no, I don't. Okay. You guys, okay, I'm sorry. You guys semi with me? Okay. So at the end, I have to square root to undo this weird ass square. Why did we have to square? To make it not negative, and so we're on the nice plane, not the evil plane. Okay. Again, if you're at home, I'm sorry, you missed all of it. Okay. So what do I get when I square all these things? I get 4, 0, 0, 0, 4. Okay. So what I'm going to get right now is I'm going to get an average squared distance from the mean to each data point. Because don't I have these squared distances? Don't I have those? I have those, right? Yes? Does everybody agree that's the squared distance from the data point to the mean? Yes? So now, can I get an average of those? What would I do to get an average of those? I would just add them all up, divided by how many there are. Holy shit, yes? What's the symbol for add them all up? The serious looking E, dude? I want to add up these and divide by how many there are, and the symbol for this is little fat r dude squared. It's the little lowercase sigma squared. And not surprisingly, we chose lowercase sigma because that's the Greek letter S. And this is spread, but more officially, it's called standard deviation. This, by the way, is the variance. Because what did we say we had to do at the end to undo the square? Square root. Then we get the standard deviation. Okay. Let me stop for a minute. Because this is huge. This is a huge deal. Okay. So see what we get. The first place people mess up is you think you're supposed to put numbers here. No. What is the sum of this? What do you get when you add these up? 8. So the sum of these is 8. So what do I put in place of this whole damn thing? I put freaking 8. How many numbers were there? 5. And what's 8 divided by 5?
1.6.
1.6. Cool. I like it. Let me make sure I'm getting all this. Yeah. For the most part, yeah. Okay. Okay. Y'all with me so far? This is weird. I really want you. You don't have to be the point where you're like, I could do all of that. No. I just want you to understand the idea, right? This is something you don't get to see very often. You don't get to see the construction of a formula. And this is the power of math. We go, I want to know this. What do I do to make this tell me that? I do this shit. This is what I do. Okay, so to get the standard deviation, I have to take the square root of that. Can somebody help me out? What's the square root of 1.6? I like the idea, but not quite.
1.26.
Keep going.
4911064.
Blah, blah, blah. So always, always, always round standard deviation to at least 3 decimal places. 1.26. What would this be? 5. What that means is that each data point here gets that far away from the mean on average. Okay, that's all. That's what that means. Okay, I like it. So, if we did all the same work for this set of data, would our answer be smaller or bigger than that? What did we say earlier? Which one was more spread out? 2. So should our answer be bigger or smaller if we do it for this? Bigger, because this is more spread out. That's supposed to be a measure of how spread out this data is, right? All right, some of you guys have checked out. Stay with me, stay with me. Okay. So let's do this one, because then I have one I want you to do on your own on a sheet of paper. What have I done? There. Oh, you're both equally terrible. So, stick this away. Blah, blah, blah. Blah, 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 blah. Blah, 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 blah. Blah, blah. Okay. So if I put 1, 2, 3, 4, 5. 1 minus 3. That's right, kids. And then 2 minus 3. 0, 1, 2, yes?
Yes.
Then I square each one of them to kill the negatives. 4, 1, 4. Then I add these up, and that's what goes in this whole freaking thing. That is the one big difference between stats and algebra. It's not even a difference, to be honest. But you guys aren't used to replacing the entire thing with one number. But this means the sum of these. Well, if I add these up, I know what the whole damn thing is. 10. So a 10 goes right there. Divided by 5 is 2. That's the variance. Standard deviation is the square root of that. You can double check me. And what was the, I should have kept the other one. The other one was 1.2 something, right?
2.265.
And this is a little bit bigger, which makes sense because it's a little bit more, is it a lot more spread out? No, it's a little bit more spread out, so it's a little bit bigger. Beautiful, that number seems to do exactly what it's supposed to do. What's the only way you would get a 0 there?
They were all the.
If every single one was the same, and why does it make sense? If every single one is the same, what's the spread of the data? Freaking 0. Can the standard deviation ever be negative?
No.
Exactly. What sense would that make? Mathematically, I'm squaring and square rooting. That can't ever come out negative, correct? Conceptually, it's how spread out the data is. What would a negative spread mean? Like it's a black hole number. What's my data? Don't look at it too often. You get sucked into it. No, right? So you can't have a negative standard deviation. Okay, I like it. Okay, so let me give you this. I have a handout, believe it or not, where I have a completely worked out problem on one side, and the other side is the problem I want you guys to work on. Oh, before I do this, I'm actually remembering this. This is big. This is so huge. Okay. I don't think I've ever remembered to do this before I gave this damn sheet out, so I'm a little excited. Okay. So everybody got what they want from this? Yeah. More than you wanted? Okay. Take our planes away too. Oh my God. I need to hire. Oh shit! You know there's a quiz on TikTok. I need to hire a camera person and a border. One huge thing is what I said earlier. You have a population standard deviation, which is, let me just put the formula up here. That is the population standard deviation. How do I know it's a population? It's a Greek letter, right? That's one way. Not every single population thing is a Greek, but right now, it currently is. That's a population mean because it's a Greek. That's a population standard deviation. If I take a sample, and then I want to know the standard deviation of the sample. Let me see if you guys are cool with this. Let's see. If I took everybody's ages in here, that's my population, correct? Of people in this room, that's my population. You with me? Including me. I'll throw myself in there and just throw things on. And then I calculate the standard deviation of the ages. You with me? I would do it exactly like that. Now, let me see if you guys get this. If I only did this row, if I took a sample of everybody, and this is my sample, you guys, are these people, are their ages closer to the average of them, or are they closer to the average of everybody? The average of them. Could they all be relatively younger than the rest of us?
Yeah.
Yes. And I'm sorry I picked you guys. Just sit there, you have to do it. So then their ages would be closer to the average of this group, correct? Yes? Okay. If I only take this sample, what key thing do I not know? I don't know the population mean. I only know the sample mean, correct? Since their ages would be closer to their mean, is the standard deviation going to be bigger or smaller than it really should be?
Smaller.
Smaller, because again, standard deviation measures the spread. If they, and we know this is true, they are closer to their average, that standard deviation is going to be smaller than it really should be. You guys sort of with me so far?
Yeah.
Okay, so I'm trying to think of what order to do this. Keep that in mind. So a sample standard deviation, if I did this exact same work, but I had the next bar there, it's going to be a little smaller than it really should be. Second thing. Keep that in mind. Second thing. If I have three, for example, three numbers, And I know that they average to be 10. Do you know what any of the numbers are? I have no freaking clue. How many of the numbers can I just make up? No. 18, 20, 78. Is the average 10? If I know the average must be 10,
Oh, you can make a pool.
I can make up 2 of them. Let's test that out. Somebody give me a reasonable size number.
100. Okay, I thought you meant like. Okay.
The average is 10, so give me a reasonable number. 5. I love it. Somebody else give me a slightly bigger.
7.
7. Okay. Does anyone know what that last number has to be to make the average 10?
It has to be.
No, I want to know exactly what it has to be.
Has to be
Add up to 30,
Beautiful.
right?
So real quick, if I average 3 numbers and the answer is 10, they must have added to be 30, correct? Because how do I calculate average? Add them up, divide by how many there are. So what number divided by 3 is 10? 30. So I don't know what any data points are, but I know they add to be 30, correct? So I can just make up, I could have made one of them 100. So I'm sorry I shut you down, but I just didn't want to at the moment. As long as, and I can make up all the shit I want to until I get to the last 2. That's where I gotta get serious. So now I've made it, since I picked that to be 5 and that to be 7, this one's gotta be 18. That's the only way to make the average 10. If I would have made the first one 100, and the next one 130, let's say, what would the last one have to be? Understand that it could go negative.
Negative 200.
Negative 200. So, with 3 data points, how much freedom do we have? How many data points are we free to just make whatever you want them to be? 2. If I had 100 data points, how many of them can I just totally freaking make up?
99.
99. So there's a very important idea in mathematics, yes?
I'm just a little confused, like, why.
Oh, okay. So again, if I know the average is 10, and that came from the sum of them divided by 3, then I know the sum of them must be 30, yes? So that's why 100 plus 130 is 230. That one's got to be negative 200 to make the average 10, to make the sum 30. Okay. The bigger point here is, however many things I've got, however many blank places I've got, I can make this many of them anything I want. And we call this the degrees of freedom. Holy shit, what did I, oh, that's good job. Oh, occupational hazard. I just unplugged the main power. Okay. Poor little dude. It's a little overzealous. Okay, there. This is going, right now, to be honest, this name isn't a big deal, but I kind of like to tell you now because it's going to show up a lot in the 3rd part of this course. And I will say it as degrees of freedom because I'm a dork, so you're just going to have to deal with it. Anybody get that reference?
Braveheart.
Yeah, lightning out of his butt, all kinds of. So, here's the point. If I want to calculate the sample standard deviation, the first difference is it's just going to be the letter S. It's not Greek because it's not a population. The next difference, of course, is going to be, this is going to be what instead? For a sample. No, what's the symbol for mean for a sample? X bar. And then the biggest difference is that instead of dividing by n, we divide by n minus 1. And the idea is there's one data point we don't know, and that is the number that would make the average what it's supposed to be. So we sort of do this, we divide by 1 less. And why does this make sense with what I said earlier? Didn't we say the spread would be a little smaller than it's supposed to? If I use this formula, that's what we said earlier? You guys remember? How do I make a number bigger? I divide by less. So this would make it come out a little bigger. So the quick way to remember this is, this n minus 1 is an adjustment if it's just a poor little sample. We have to adjust it a little bit because it's just a poor little sample. And to remind you guys, we will have a formula sheet that we will create together on the review day that you can use on the test. Okay. You won't be able to write words next to stuff, but you know. So, next thing. Oh, this is the second thing I'm so excited I remembered. How the shit do we use standard deviation? What good is it? Let me give you a couple of visuals. Because we've only been talking about pure numbers so far. So if I have a distribution that looks like this, and I have another one that looks like this, let's say they both have the same mean, right? Which one is more spread out?
The second one.
Second one, correct? Standard deviation, all right, let me say this. If I want to measure the distance between two people in this room, would I use miles?
No.
Could I use miles?
Yeah.
Does miles make sense?
No.
No. If I want to measure the distance between two cities, would I use inches?
No.
Could I use inches?
Yes.
Okay. So there's a natural kind of scale to use based on how spread out things are in general. So you guys are not spread out on the scale of miles, correct? You guys are spread out in like feet, maybe sometimes even inches, but feet would be good. Yes? Cities, miles. Stars, light years. Okay, so there's a natural tick mark to use in a lot of situations. In statistics, the way I tell how far away something is from the mean, I use standard deviations. If something is one standard deviation away from the mean, that means it's about the average distance away. Would that be an unusual thing? No, it's about the average distance away. If something was 5 standard deviations away from the mean, that is 5 times the average distance. That is an outlier. So the way we measure distance in statistics is through standard deviations. I like it. So watch this. Let's say the mean here is 10, and let's say the standard deviation is, what do you got, Jeff? You can do it, buddy. 2. The mean here is 10, and the standard deviation here is 5. You can do it, buddy. 16. How many standard deviations is 16 away from 10 for this first picture? Everybody with that? It's 3, yes? Because 3 steps of 2 gets you from 10 to 16. Okay, now you could answer that question and not even know what you just did. What about this one? How many standard deviations is 16 away from 10 here?
1.2.
Say again?
1.2.
How'd you get that?
Because one standard deviation is 5.
Okay.
So you're adding at least, because we know it's 16, so you add 5, and then 1 more.
Okay, I'm with you. I'm with you. I
number
love
5
it.
is-
I love it. But here, let's do something. How far do I have to go? 6. How big is each step I take? So I will sometimes use the word step for standard deviation. So if I have data that's really, really not spread out, I want to take tiny steps. Because if I take big steps, I miss the whole damn thing. Yes? Have you guys ever driven across the United States and there's a town that if you blink, you miss it?
Yeah.
Okay. So if you're going too fast, you're going to miss something. So if my data is really, really narrow, I want to take tiny little steps, right? If my data is really spread out, I want to take big ass steps. So I often call standard deviation steps. Okay. This one was 16 minus 10 divided by 2. That's how many steps fit into how far I want to go. This is going to be 16 minus 10 divided by 5. And that is, like you said, 1.2. And this was 3. Right? Why does it make sense that 16 is relatively further away there? Because more of the data is close, so 16 should be relatively far away. You guys semi with me? This 16 is much closer to the mean because every step I take is bigger. I can get to it faster. I only have to take 1.2 steps, whereas here I have to take 3 steps. Maybe. Shit, now I got the Mario thing going. Okay. All right. So this is huge. This is huge, what we just did. Standard deviation is stupid important. What we just did here was see if I can. So if I wanted to measure how far apart two people are, I could take if I was anywhere else in the world, I'd use a meter stick. But here I could take a yardstick, yes? And then I would just count how many feet. You with me? Standard deviation is the tick marks. Inches, feet, miles. This, what we just did, this is called a z-score. A z-score is when I actually lay the ruler down and make a measurement. That's what a z-score is. So here comes a really important definition. And I'm just going to tell you this right now. What I'm about to say is going to be a question on every test. And someday I'll get 100% of people getting it right. Okay? I'm going to tell you the answer. Does everybody understand? What does every student want? Just tell me what's on the test. I'm going to do one, but I'm going to tell you the freaking answer. What does a z-score tell you? The number of steps from the mean to a data point. Let me say that again. I'm going to be more specific. I'm sorry. Now, don't put steps. When you answer this on the test, you got to actually say standard deviations. So a z-score is the number of standard deviations from the mean to a data point. So can you tell me what the z-score is going to be for the mean always?
Yeah.
If the z-score is the number of steps from the mean to whatever data point, what's the z-score for the mean itself?
Always positive.
Freaking 0. How far is the mean away from itself? 0. Right. Can the z-score be negative?
No.
Yes.
Yes.
A negative z-score just means I go down. So if on a test you scored below the average, your z-score is negative. So if I have a z of 1, that means go up 1 step. If I have z of negative 1, that means go down 1 step. Is that cool?
Yeah.
Okay. And again, there's a lot right now that you don't have to 100% understand. I'm just trying to lay some groundwork. Right? The amount that you're going to use this in chapter 2 is very minimal. But we're going to use the hell out of it once we get to especially chapter 6. It's just going to be dominating everything we do. Okay. All right. Let me shut up. So one side of this, completely worked out problem. It has questions like what I like to ask. Other side is something I need you to do. Okay. All right, so I'll leave this up to you. You can either get together with other people near you or you can try to do this on your own. So one side, again, completely worked out. This side I need you to do. Be really careful. Oh, by the way, let me show you. There's so much. Let me show you how to use your calculator to construct this kind of table we did earlier. I have the instructions on that sheet, but let me just show you. Let's do this side that's already worked out. I want to show you how to get those numbers just in your calculator real quick. Are you on? Yes, that's useful. Thank you. It's amazing. I always forget something. All right. Shake up. No, camera. Okay. So real quick, just to kind of, so you can see up here I tell you. So on this problem, can anyone tell me why that's a 5?
That's bar X, right?
Say again?
Is it bar X?
That's X bar, yeah. So it's not always going to be 5, you understand? Do you understand that a student might look at that and say, oh, that's always 5. It's whatever the mean is. So when you do your problem, you calculate the mean and do not round it. Okay. So let's see if we can count. So I'm going to clear out list 1. Clear. I'm just going to put the data 1, 2, 5, 8, 9. Now watch this. This is the first time we're doing this, so this is kind of important. Okay. Don't I want list 2? Why does this make sense? I want it to be x minus x bar. Well, where are the x's? List 1. So I want list 2 to be list 1 minus, in this case, 5, right? You make sure you go, I don't want to put an entire list in this one spot. Go up to list 2. There you go. Now you see how the bottom says list 2 equals? Now I can control the whole damn list. So on list 2 to be list 1 minus 5. Let's see if I get the same numbers Hash Jeff got. Yay. You guys with me? You guys see how that worked? So real quick, I just want to show you. If I try to put it here, list 1 minus 5, the calculator's going to go, what the shit? Data type, meaning you're trying to put a type of data that is a whole list into one piece of a list. And the calculator, what the shit? So if I go to, I'm like, oh shit, up. L2 is L1 minus 5. Sweet. L3, I want that to be L2 squared, right? Exactly like we did, well, it's gone now, but exactly like we did earlier. So I'm going to go up to L3 and make it L2 squared. And then I get the same numbers. Yay! Okay. So now you guys do this side. Catch up to you a little bit. So I sorted this stuff, so if you want to sort it, that's good, because then you can kind of check your answers against what I get. Oh, by the way, what'd you get for the mean? Anybody got the mean?
6.5.
Yeah, that sounds about right. 12, 6 times 13 is 78.
78 divided by 12.
Yeah. All right. Why, real quick, why should you not round the mean? Or if you round it, you should round it not a lot.
Change the answer.
Yeah, because the standard deviation is a measure of how far with the mean you are. So if you change what the mean is, you've completely changed what the spread is. Okay, I love it. So I want this one to be, I want list 2 to be list 1 minus the mean we just calculated. Enter. So on a test or a quiz or on homework, you would just copy all that stuff down into the table. Right? In the interest of time, I'm not going to do that.
Do that.
Hmm?
I'm trying to figure out how you do that.
Oh, sorry. I'll do it again. Did you sort list 1, by the way?
Yeah, I got this one already sorted.
Okay, so go up to list 2, because then it can control what the list 2 is. And I want it to be second 1 for list 1 minus the mean, because list 1 has all my x's. So if I want x minus the mean, I want list 1 stuff minus 6.5. And that's how I got all those. Sweet. And if you add all of these right now, what you don't even do it. Can somebody tell me what you would get? 0. That's why we do the next thing. What do I want to do next to get list 3? Square what? List 2. List 2's got the x minus x bars, and I want to have those squared, so I do go up to L3. I'm going to say second 2 square list 2. Kabam. And then on a test or on the homework, you would copy all that shit down. Okay, now let me show you a quick way to add that up, because you don't want to put 20.55, you know. Here's a quick way to add that up. You ready? First thing is, has everybody got that, by the way? Everybody with me?
I'm still trying to figure out how to get it. I can't do it.
Oh shit. Well, good luck.
Yeah.
Sorry.
I'm just manually putting it in.
Maybe just watch.
Take a
Okay.
picture. I'm just gonna take a picture real quick.
Okay. Yeah, I have no idea, buddy. Yeah. If I go second mode to quit, do that first. Second mode to quit. Quit's a really cool button. Right? Don't you wish we had just the quit button or something? Done with today, quit. Now, see above stat where it says list? What do we want to do right now? What's the next thing we want to do for this formula right here? What do I want to do? What do I want to do with all these numbers that are in this list? Add them up. So I want to do something to list 3, don't I? I want to sum it up. So let's do the list. Let's go second stat to list. I want to do math to a list. I want to sum up a list. See that? Also notice all the other shit you could do. So let me pick number 5. And I want to sum up list what? 3. 69. I was waiting for somebody. All right. So that whole thing then is 69. So is everybody with what just happened? Oh, let me do it again. So the minute you lose me when we're doing technology, you gotta let me know. So is everybody cool with how L1, L2, and L3 were constructed? Okay. Second mode to quit. Second stat, because I want to do something to a list. So it makes sense to go into the part of the calculator that says list. I want to do math to a list. I want to sum up a list. And I want to sum up second 3, L3. That's the quick way to add those up, right? So now I can throw that into the formula. What goes on the top of this formula? Good. And what goes on the bottom? How many grades were there? So 11. And again, why is that n minus 1? Because this is just a sample. The n minus 1 is an adjustment for it being a poor little sample. So what do you get when you do this? Right? But just to remind you guys, you don't want to round anything till the end. So remember what I said yesterday? So right now I can kind of round it to put it down on my paper, right? But in the calculator, I want to take the square root of that number. What's a quick way to do that? A and S button, right? Second negative, square root of that number, and there it is. So that is my standard deviation. So on average, these data points get 2.5 away from the middle, away from the mean. Oh shit, well I did all that up here, too bad. 2.505. Dadgummit. Okay. And let me show you this right now. I might as well show you this. And this is where I'm going to get students say, why did we just do all that shit, Jeff? Well, let me show you. Let me first show you this. If you hit stat, do you remember doing it for the 5-number summary? We went stat, calc, 1 variable stats. Do you guys remember that doing that? And the last thing it shows me is the 5-number summary. Look what else it shows me. Do you guys notice anything? Like, what's the very first thing it tells me? Freaking me. Notice how it gives me both S and sigma, correct? Why does it do that? Because the calculator is dumb. It's stupid. It's a piece of plastic with some electronics in it, right? Stupid. And so it says like, here, human, which one do we pick? The one for the situation. We're in a situation where we know the sample, so of course we're going to pick S. Is that what we got just now? Yes. So that's a nice way to check your work. It's not a good way to do your work. I love it. Because otherwise the calculator passes the class, it goes on and has a nice life, and you take the class over. Right? Calculator sends you little postcards, little pictures of it. Oh, look at the little baby calculators. Oh. Sorry. Oh man, you're sorry. You think you're funny, math boy. Okay. So now I can do something, and I told you now already, this is the z-score. If I want to know how many standard deviations from the mean to a data point of 8. 8 minus, what was the mean? Divided by the spread, the standard deviation. Technically, you should use the whole number here, but I'm telling you, round to at least 3 decimal places, and that should keep us safe in terms of rounding errors. So whatever the hell that is. By the way, real quick, is 8 a full step away from 6.5?
No.
2.5 up from 6.5 is 9. So the answer should be a little less than 1. It should be positive because 8's above 6.5, correct? But it should be a little less than 1. And what do you guys get?
5.405.
Sorry, say it again.
5.405.
5?
5.405, so she's saying.
I got 0.5.
Oh, let me see what you did. Let me see. Did you do this? That's it. Okay, I'm sorry. I'm not picking on you or anything.
Yeah.
Real quick, first day we talked about this. What am I supposed to divide? I'm supposed to divide what the difference is. That is only dividing 6.5 by that. So you have to put, and please, dear God, understand, somebody else just made that same mistake, not just you. So you got to tell that poor little calculator. Poor little calculator has no eyeballs. Thank God, because I don't want it in my, bouncing around my backpack and like poking its eyeball. There. Yes?
Can you just put in the fractions, at least for those you have a fraction button?
Oh yeah, if you want it, yeah. So, I mean, if you want to, but there's going to be more involved. I guess it would work. There is a fraction button, if I remember where here we go. But, I'll let you investigate that. Otherwise, you just use parentheses. Yeah. You got to tell the calculator where the top is. And there's only one thing on the bottom, so I don't have to put parentheses around that. So is everybody okay with that? And it makes sense. I knew it should have been less than a full step. So it's 60% of a step. It's 0.6 steps. Okay. So what is that? 5. Let's make it 0.60. Okay. Oh, shit. Now. Oh, man. This is the thing I hoped I had enough time for, but I'm going to stick to my promise that we're going to get out a little early. Last thing here. All right. Okay, here we go. There is a theory that we're going to talk about. It's actually called a rule. So we're going to talk about it first thing next time, but it's related to what we're just now about to do. I want to know what percentage of the data is within one step away from the mean. So if I go one step up and one step down from the mean, what percentage of the data is in there? So let's calculate that. What's the mean? What's one step up? No. Is every step 1?
No.
How big is each step? 2.505. So what's one step up? 9.005. Yes? What's one step down?
995.
Minus 2.505. What is it? 3.995. Now, how many data points are between those? Yeah, starting at 4, and then the last one I include is 9. So there's 1, 2, 3 that aren't in there, correct? So the 2 isn't in there, and the 10s are not in there. Are you guys with me? What data points are between these? The 4s for sure, right? The 4s up through the 9s, yes? So what did we not include? That 1, 2, and there's 2 10s. There were 12 data points. So how many data points are in there? 9 out of 12, which is 75%. Okay. Oh shit. So right now, I'm very sorry. It's too big of an idea to get into right now, but very first thing we'll do next time after the quiz is talk about what's called the empirical rule. It talks about what percentage lies within 1 step, within 2 steps, within 3 steps. And that's going to be kind of big for later. Yes?
So what did you just do? Sorry.
Oh, do you agree with me that there's 9 data points in here?
Oh.
Out of
Yeah.
12, so 75% of the data is within 1 step, within 1 standard deviation.
Between 4 and 9.
Yes, I like it. Oh yeah, oh man. So, we have a nice long weekend. Remember, Monday don't come. If you come, okay. You just sit here by yourself if you get on campus. Tuesday, first thing, we got that quiz. The quiz is going to be 2-1 through 2-4. Basically, stem leaf plot, histograms, and box plots, percentiles. Right? Okay. And oh, I did give you guys a practice test. Yes. I'll have the answer key for the practice test next Wednesday because our test is on.
Tuesday.
Our test is on Thursday. Okay. I can put it Tuesday.
I'm thinking of the quiz.
Oh, the quiz is on Tuesday.
That's the
All right, guys. That's plenty. Have a good weekend.
Are you posting quiz to campus?
Say again?
Are you gonna post that quiz scores to campus?
No, I don't use Canvas for shit. Yeah. I don't like it. I was just going to give you your quizzes. If you want to know your quiz grade before, you can just email me anytime. Yeah.